Hello and welcome to the series of lectures on big data. Today, we are continuing the previous discussion of Hadoop. Up till now, we have discussed that what is the use of this framework called Hadoop. Hadoop is a open source Java programming based framework which allows the user to store large size of data and to process that data set in parallel as well as distributed fashion. Also, we know that Hadoop has two main components. The first component of Hadoop is known as Hdfs, which is Hadoop Distributed File System. And the second component of Hadoop is MapReduce, which is the processing unit. Now, because the problem was storage of unstructured data and the processing of that large data set. And these two problems were stored and solved by Hadoop. Now, storage unit of Hadoop, Hdfs, allows the user to dump any type of data, whether it is structured, unstructured or semi-structured, over its cluster. And MapReduce allows the user to process that stored data or dumped data in parallel manner. So, in this way, the problems of big data are solved. Now, Hdfs follows the master-slave architecture, right? So, the master here was the name node and the slaves are the data nodes. We already completed the discussion on what are these name nodes and data nodes doing. Name node are basically containing the metadata of data nodes. The actual data that we are writing or reading is being dumped on the data nodes. These data nodes are nothing but the commodity hardwares. Now, name node maintains a record about all the data blocks that are stored in these data nodes, right? If I'm dumping a file X, where this file is saved, where we have dumped this file, where Hdfs is storing this file, the location will be any of the data nodes or more than one data nodes, right? So, this file will be dumped actually on these data nodes. But this name node, which is the master, because it is the master of this structure, of this architecture, so definitely this master node will be handling all the input and output from these data nodes. Moving forward, the data nodes basically contain the data blocks. And these data blocks are nothing but the actual data, actual files that we are dumping on the Hdfs, right? So, this is how Hdfs structure looks like. Now, we know if I am dumping a file, let's say X, and which is of a larger size, let's say 380 MB. So, it is a large size file. What I have to do before dumping it or storing it into Hdfs or data nodes, what I have to do, I have to divide these files. I have to break these files into smaller chunks, smaller files. And after this division of these files, we will dump them into the data nodes, right? So, you can see if I am having a file, let's say the size is 512. So, we will be having 4 different 128 sized chunks. And how we are deciding that they will be divided into only 128 MB chunks? Because the default rate of Hdfs while dividing these block sizes is 128 MB, which can be customized as well. It can be customized, it can be changed as well, right? We can configure this size. So, whenever we have a smaller sized file, we can directly dump it on the data nodes. Whereas, if the size of the file that we are storing or writing on Hdfs is higher than the standard block size, we need to divide them, we need to partition them. For example, if I'm having a file, let's say 130 MB. if I'm having a file, let's say 130 MB, then what I'll be doing before storing them onto the data nodes, your HDFS will identify what is the size of the file. It is 130 MB. Is it greater than the block size? Yes, it is greater than the fixed block size which we are having, that is 128 MB. So, it will divide this file into two chunks. The first chunk will be of 128 MB size and the second block will be of 2 MB size. And then we will be dumping these two files on the data nodes, right? This is how HDFS block works. Now, we have already understood that the core components of HDFS, one is the name node, another is the data node. Name node is the master node, data nodes are the slave nodes. Name node controls all the management of data nodes. Data nodes are the commodity hardwares that are actually storing the data. But as you can see in this diagram, along with name node, we are also having a component called secondary name node, right? Now, these secondary name nodes are often confused with the metadata or the table, which is the copy or the replica of name node. But actually, these secondary name nodes are the tables that are helping to maintain a database or the metadata of name node, right? Let us understand what these secondary name nodes are and what are their functionalities. Now, understand this. The name node has two things while storing the metadata about data nodes. The first thing it has is FS image. And the second thing that we are having in name node is edit logs. Now, FS image stands for file system image. Now, these FS image and edit log, they combine to form name nodes. All the information about the data blocks that are being stored on data nodes are present in FS image as well as edit logs. And with the help of these two components, name node is working as master node. As you can see parallelly, we are also having a secondary name node in the background. Now, the secondary name node is just like a tabular structure of the name node, which is storing metadata about name node. It means because name node was storing metadata of data nodes, in the same way, secondary name node is working as a method of storage of metadata as name nodes. So, basically, the functionality of secondary name node is to process a function called checkpointing. Majorly, it performs a function called checkpointing. And what is checkpointing? Checkpointing is a process of combining these edit logs with FS image. Now, understand this. The FS image contains all the information about the name node from the starting of name node. For example, if the name node or that entire architecture has been dumped in HDFS 20 days back. So, from that first day onwards, when the name node was created, FS image will also be created parallelly. What this FS image will contain? This FS image will contain all the information, all the changes that has been done in the name node. Right? Let's say up till now, it is the first day of creation of name node, and because name node 1 is created today only, it might be having very few information. Let's say how many number of data nodes are associated with this name node. Up till now, number of data nodes associated are 3. What is the information in data nodes? Let's say in data node 1, we are having 2 files. In data node 2, we are having 3 files. And in data node 3, there are only one file. There is only one file. So initially, this much information is present because we have recently created the name node. Next, what will happen? After this, of course, because name node it's storing the metadata about all the data nodes, then definitely it will be having the details of all these files that has been stored. For example, what is the size of the file that has been stored on data nodes? Let's say there are two files, so definitely 1A is the file, 1B is the file. What is the size? When it was created? What are the permission? What is the hierarchy structure? All these information are stored in name node. Now, what FSImage is doing? FSImage is maintaining a log of all the changes that are being done in name node. For example, let's say you are performing a write operation where you are deleting a data block. Let's say you have deleted 1B now. Once you delete 1B, 1B will be deleted. Let's say 1B is here also. So 1 will be removed from this data node. It means we'll remove this block from data node. Second step will be that name node will remove this entry also. So now we have changed an entry in name node, as you can see here. Now once we start changing this entry, the FSImage will update its directory, right? So it will update its directory about the name node. So before it was storing only 1, 2 and 3 data nodes in name node. How many files are there? There are 3 files, there were 2 files, there were 2 files, there were 3 files and there is only 1 file. So now only 1 file has been remaining, so it will update its log as well, right? So FSImage is working as a namespace of this name node. And what are these edit logs? These edit logs are maintaining a record of the recent update or recent change that has been done. Now, what is the difference between these two? Again, let's take an example. As I told you, let us imagine this name node has been created 20 days back. So, FSImage will be created 20 days back and it will be holding all the changes from the beginning to the present date that has been done on the name node. Whereas, edit log will contain the records of the changes that might be happened in last 1 hour. Right? So, they will be having only recent changes that are done in name node. And this FSImage is nothing but the namespace of this file system name node, which will contain all the changes. All the changes. From where? From the first day onwards. From the first day onwards. It means from the day name node has been created, FSImage has been also created. And this FSImage will have all the changes, record of all the changes that has been done in name node from day 1 onwards. Right? Now, what else this secondary name node is doing? The secondary name node was doing checkpointing process, which was the combining of FSImage and edit logs. Why we are performing checkpointing, we'll understand in the next page and how we are doing that. And what else secondary name node is doing? It allows the fast failover as we have a backup of the metadata. Let us say at any point of time, this name node stops working. Right? Let's say this name node stops working. It fails. It crashes. Then what happens? We can easily go to the secondary name node and got all the information about the name node. How we can do that? Because it is having FSImage as well as edit logs. And it is performing a process called checkpointing. So it is having all the information that has been stored in the name node. So as soon as this name node stops working, we can easily replace a new name node with this one and we can copy all the information in the new name node. Right? So this is how we can have a faster recovery rate from the failover. And the checkpointing process happens periodically. It not only happens after 1 minute or 2 minutes, the default rate of checkpointing process is 1 hour. It means after every 1 hour, this secondary name node is going to perform check pointing process. It means it will take fs image and edit log, it will add them, merge them, and then again update its log. Right? This is what the role of secondary name node is. Now, let us understand what this check pointing process is actually working on. As you can see here, there is a node defining the name node and another is the secondary name node. So we know that name node is having two important components that helps us in working and maintaining the metadata. One is the edit log, another is the fs image. Edit log are the one or the directory that stores the recent changes, and fs image is the one that stores all the changes, that has the account of all the changes that has been done, all the updation that has been done in the name node, right? So let us not look here. Let us first understand what is going on this side of the page. So edit log and fs image are there. Now secondary name node has to perform check pointing process. In this check pointing process, it combines the edit log with the fs image. Now, as I gave you an example, let us take an example. I have recently removed 1b from name node. There is a change in name node. There is a change in the metadata of the name node. So, what fs image is going to do? It is going to maintain this record that 1b from a data node, let's say 1, has been removed. At what time? Who has removed it? What was the validation for that? So fs image is keeping a copy of that. In the same way, because the change has occurred recently, the edit log will also maintain that change, right? So the edit log will also maintain this change that has been done in name node, that 1b has been removed from this data node at this time by this client or this user, right? After 1 hour, what the secondary name node is going to do, it is going to take a copy of this edit log and it will take a copy of this fs image with it. It means it will take the copy of both of these components with it and it will combine these copies. Why it is combining these copies? To make a new copy of fs image, to make a fresh copy of fs image which is having all the updations. Right? Now, as soon as the edit log will be updated, it will be combined with fs image. Fs image will be combined with edit log and will produce a new fs image where all the changes that has been done are updated. It will cross check the changes and then we will send this new copy to the name node. It means now we will maintain the fresh copy of this new fs image in the name node as well, right? So this will be removed with new fs image. The name will be same, but I am writing it, it will be removed from new fs image, which is the final fs image, right? So after every 1 hour, whatever the changes have been made, we are going to update them and keep a new copy of fs image in the name node, right? We are not keeping the copy in the secondary name node because it depends on the current scenario or the changes that have been done. Now, while performing this entire process, which is known as check pointing, at the backdrop, we are keeping a edit log copy as well. Now, this edit log copy is temporary while making the checkpoint process going on. Why we are making this temporary copy of edit log? Because in between, while performing check pointing process, if any of the changes are lost in edit log, or let's say while performing check pointing, if name node stops working, so what we can have a backup of this edit log. As soon we complete the check pointing process, we will maintain and remove this edit log from here. Right? So it is temporarily a copy to secure the changes that have been done in the edit log. Right? So this is how this entire check pointing process is going on with the help of in the secondary name node. Now understand this, the secondary name node takes over the responsibility of checkpointing process after every 1 hour, right? Now, to allow faster failover, as we already discussed, it prevents the edit logs from getting too huge. Now, why we are performing this checkpointing process every 1 hour? Because we want to update the data quickly so that we do not have the pile of data while of changes or updation that has been done. So that is why we do that after 1 hour. If we stop doing this checkpointing process, what will happen? This FS image will be growing higher and higher side, and this edit log will also be at the higher size of the size. And this will give us a demerit that again, the name node was only having metadata and will be adding too much information in the name node that again will be needing higher servers, larger servers to store these edit logs and FS image as well, right? So this was all about the core components of Hadoop distributed file system. Thank you very much, everyone.